So, going over the review sheet today, test is tomorrow. We're going to work through some of these problems here. Now, I will say this, a lot of the problems, I mean, there are 29 problems on here on the review sheet. The 25 and 26 that are going over grouping is not on the test. There aren't going to be any problems that ask you to factor by grouping. 2, there are none that are not factorable. There's 3 that all you can do is factor out a greatest common factor. But there are none that just are not factorable at all. So you are going to be able to factor out a greatest common factor. There's 1 of those on part 1, 2 of them on part 2, where all you do is factor out greatest common factor, we're done. But the rest should have sets of parentheses, multiple sets of parentheses. If we look at number 1, 6a cubed b squared minus 36ab squared plus 71a squared b squared. There is a greatest common factor of a in all 3 terms. They also all 3 have b squared. Now 6, 36, and 71, we'd have to see if there's a number in common with all 3. The biggest one we could definitely possibly have is 6. But 71 divided by 6 doesn't work. 6 is also divisible by 3. Well, 71 is not, so that doesn't make a difference. And well, we can say 71 is also not divisible by 2. So that tells me the only greatest common factor between 6, 36, and 71 is 1. It doesn't help. So the 6, if we factor out this greatest common factor, would still be there. If I factor an a out of a cubed, we're left with a squared. And the b squared will factor out completely. Minus. We're still going to have the 36. I can factor an a out of a. I can factor a b squared out of b squared, leaving us with 36. Plus, we still have the 71. But if I factor an a out of a squared, we're left with a. If I factor the b squared out of b squared, it factors out completely, giving us this here. So ab squared. Now I'm going to rewrite it. So it's in standard form, 6a squared plus 71a minus 36. Now we could try factoring this here and going through the factoring steps, but unfortunately this does not factor. This is actually as simplified as it gets, because we could go through our 2 sets of parentheses with 3 spaces, our opposite signs, a and a, 2 and 3, for 6, 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, but none of these are going to work. And we could go through the whole list, and they're not going to factor. Erase that. Another way to check is our b squared minus 4ac to see if it is factorable, because it's telling us the type of solutions or part of the solution we'll have. Because here we'd have second square root 71 squared minus 4 times 6 times 36. It gives me an irrational number, telling me that the solutions are going to be irrational. We don't have irrational factors, so that's as far as it goes. But again, in the first part, there's only one that's just going to be greatest common factor factored out. Questions on 1? Questions on number 2? Do you feel good about 1 and 2? Okay. Still good with 1 and 2? Maxie? Okay, just making sure. Questions on 2 and 3? Actually, we can make this pretty simple. 2 through 7. So questions on any one from the front. Any one of those there. Or just any of them that you even want to just see worked or done. 2. 4x squared plus 12x plus 9. So the first thing I want to look for is greatest common factor. Because we know it's not sum or difference of 2 cubes. Sum or difference of 2 cubes has 2 terms. Then kind of the variable gives that away. We need x cubed, a cubed, variable to the third. Difference of 2 squares, we need subtraction of 2 terms. Don't have it. So then I would look for greatest common factor to do our normal factoring. 4, 12, and 9 do not have a number that goes into all 3. So we'll do our 2 sets of parentheses with 3 spaces. Now I'm going to find the sign. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Well, here the third term is positive, so the signs are going to be the same and match the sign of the middle term. Because it's also positive, we have plus and plus. If the middle term had been negative, it'd be minus and minus. Now we need to find the factors of the first and third terms. Now our first term, 4x squared. X squared, part of it's nice. It's going to be x and x. Now the factors of 4, we have 2 options, 1 and 4 or 2 and 2. Where do we want to go first? 2 and 2. Because at this point here, pick one of them. Factors of 9, 1 and 9 or 3 and 3. Which one of these do we want to choose first? 3 and 3. And last thing we want to do is check. 2x times 3, 2 times 3 is going to be 6, so we have 6x. 3 times 2x and also be positive 6x. 6x plus 6x is positive 12x. That is the middle term we wanted. So 2x plus 3 times 2x plus 3 are the correct factors. Now we can indeed write it as 2x plus 3 squared. But 2x plus 3 squared, or 2x plus 3 times 2x plus 3. These are the same answer. We don't need both, we just need at least one of them. Questions on number 2? Number 3 is going to be almost the exact same. Four, 5, 6, or 7, one of those that we want to look at. Seven. A cubed plus 1. Now we have 2 terms being added together. So there's a good chance this is a sum of 2 cubes. We don't have difference of 2 squares. But we also see that a is to the third power. So there's a good chance this is a sum of 2 cubes. And it is as long as I can rewrite a cubed as a term to the third power. Something times itself 3 times. And well, that would be a. Because a times itself 3 times would indeed be a cubed, yes? Now what times itself 3 times is 1. 1. Yep. It is the only number that is the same squared and cubed. If we took the square root of it or the cubed root of it, we get the same value. Really, if we took any root of 1, we get 1. Now, a cubed plus b cubed factors to a plus b times a squared minus ab plus b squared. That's just factor form for a sum of 2 cubes. And for our problem here, we're going to replace every A with, well, A. And we're going to replace every B with what? 1. So our A plus B would be A plus 1. Then in the bigger spot, our first one is A squared. Well, we're going to replace that A with A and get A squared. Minus AB. Well, the A is going to be replaced with A. B is going to be replaced with 1. B squared is going to become 1 squared. So once we find that A and B, what's going to go in those spots, we plug it in. Now we're going to simplify. A plus 1 is just A plus 1. There's nothing in front of the parentheses, nothing we need to simplify. Even with subtraction, A minus B, we'd still really drop the parentheses. Because the real simplifying is going to come in these 3 spots here. A squared, A times A as well, A squared. If there was a number with it, 2A, I have to square both the 2 and A. 2A times 2A would be 4A squared. Minus A times 1 is A. Plus 1 squared. 1 times 1 is 1. And that's it. Any other questions on 7? Any other questions on 1 through 7? If we feel good with the first page, we'll move on to page 2, the back of the first page. Looking at the back of the first page, we can start with 8 through 11. Any one of those in particular y'all want to look at? 11. 49x to the 4th plus 343x cubed plus 7x squared. With a problem like this here, the first thing I would look for is greatest common factor. If there's a number or term in common with all 3, well, they all have a variable x, yes? How many can I factor out? 2, because the smallest exponent attached to x is 2. So we can factor an x squared out of all 3. 49, 343, and 7. Is there a common factor amongst all 3? 7 would be the only possible one. 49 is divisible by 7. Now the question is 343. And we know it's 7 because our third term is 7. 7 is prime. It's only divisible by, or divisible factors are 1 and 7. If it's not divisible, the other 2 aren't divisible by 7, there's no other number. So we're going to factor 7x squared out. If I factor it out at 49x to the 4th, 49 divided by 7 is 7. If I factor the x squared out of x to the 4th, we're left with x squared. Because I'm not factoring out a negative or a sign, it's still going to stay plus. 343 divided by 7 is 49. Our x to the 3rd power is going to become x. Plus, if I factor 7x squared out of 7x squared, it reduces to 1. If it factors out completely, it's going to become 1. Questions on this here? Now we have 7x squared times our 7x squared plus 49x plus 1. Now at this point here, really looking at 7x squared, 49x, and 1, we're trying to use the factors of 7x squared and 1 to somehow get 49. Probably not going to work. Now if I went through and did this, 2 sets of parentheses with 3 spaces. Since the third term is positive, the signs are the same and match the sign of the middle term. Since the third term is positive, signs are the same, middle term is positive, so it's going to be plus and plus. Our only factors for 7x squared, we do have x and x, 7 and 1, yes? Factors of the third term, factors of 1 are 1 and 1. 7x times 1 is 7x. 1 times x is positive x. And 7x plus x is 8x. That is not the middle term we wanted. However, flipping the 1's isn't going to change anything, and I don't have any other factors with 1. So I'd have to look at other factors with our 7x and x. There aren't any. So that's actually as far as it goes. I can verify that by at least kind of getting a look at the solutions, because we'd say second square root. So b squared, our b term is 49, squared minus 4 times 7 times 1, irrational number. So that's actually as far as it goes. This would not be it. So this would be not necessarily look exactly like this here, but it would be one that would fall under just greatest common factor. Any other questions on 8 or 9? 10 is not factorable, so we're not even just going to look at it, because there is no sum of two squares. I talked with some earlier. It is we can put it in a factored form. It's just not factorable. Small difference, but big impact. So we good on 8 through 11. Questions on 12 through 15. 12, 13, 14, 15. One of those you want to look at. A squared minus a minus 6. So this year we're going to go through our normal factoring set because we have 3 terms. Is there a greatest common factor between these 3 terms? No. 2 sets of parentheses with 3 spaces. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, the signs are opposite. Well, here the third term is negative, so our signs are automatically opposite. One's positive and one's negative. Once we get to this point, we're going to find the factors of the first and third terms. Well, the only factors of a squared, or 1a squared, is just going to be a and a. No other choice. Factors of 6. 1 and 6, or 2 and 3. Where do we want to start? Doesn't really matter. 2 and 3. You want the 2 or 3 positive? 2 positive, 3 negative. Again, we're going to check. A times negative 3 is negative 3a. 2 times a is positive 2a. And negative 3a plus 2a is negative a. And again, we're doing this to just verify these are the correct factors. This is more just a check. If we did not get if we got positive a instead of negative a, we get the correct number but wrong sign, flip the signs. If we don't get the correct middle term, we can switch the 2 and 3. See if that changes anything. In this case, it wouldn't. I would go to 1 and 6. See if that's it. If that doesn't work, then switch the numbers in front of our a's and try again. Any other questions on 12, 13, 14, 15? We feel good with all these here? Yeah? Okay. Questions on 16, 17, or 18? Or one of those that you just want to see worked? You feel good with these? 18? Okay. 6x squared plus 53x minus 9. Now we do have some bigger numbers, so I want to see if there's a greatest common factor amongst all three, because if there is, it's going to make it easier to factor. Now, when looking at 6, 53, and 9, because there is no variable across all three, I'm trying to see what's going to be in common with all three of those, yes? Because we're trying to find a number that divides into all three. Well, what number goes into 6 and 9? 3. That's the only one, yes? So really, all I need to check and see is 53 divisible by 3. And it's not. So that tells me there is no greatest common factor amongst all three. So we can do our two sets of parentheses with 3 spaces. Now, since our third term is negative, our signs are opposite. One's going to be positive, one is going to be negative. Factors of the first and third term. So if I look at 6x squared, we know that x squared has to be x and x. Now 6 is 1 and 6, 2 and 3. The next possible factor would be 3. Well, it's 3 and 2. It's already there. Do we want to try 1 and 6 or 2 and 3? I would agree. I'd go 1 and 6. Now, the reason I would go 1 and 6 and not 2 and 3, if we think of the first and third terms numbers, would we say that 53 is farther away or closer to it? It's kind of farther away, yes? And the farther away is probably going to be bigger factors, bigger terms, or we want a bigger multiplication. So we want kind of some bigger numbers. 9. 1 and 9 or 3 and 3. We could try 3 and 3 if we wanted. 6x times negative 3 would be negative 18x. 3 times x is 3x. Negative 18 plus 3, negative 15x. We could switch the 3 and 3, but unfortunately that would give us the exact same expression. So instead of that, we can switch to 9 and 1. Now we can say this is not going to work already. I don't even have to check it. Because if we look at that first set of parentheses, 6x, make sure plus 9. As we said already, the 6 and 9 has a common factor of 3. If it works, and this works, that means the original had to have a common factor of 3. Because if we can factor it out in parentheses, it had to be there at the top. So instead, we can do this here. 6x times negative 9. 6 times negative 9 is negative 54x. 1 times x is plus x. Giving us negative 53x. Now that is the correct number, but it is the wrong sign. We want it to be positive, not negative. So the first thing we can do, or the main thing we can do, is switch the signs. Questions on this here? Because if we checked it again, it would make this be positive 54x minus x, giving us positive 53x that we wanted. Any other questions on 8 through 18? We feel good with the back of the first page. Yes? Okay. Questions on 19 through 24? Yes? 24. 186a cubed b squared minus 9ab cubed c plus 117a squared b to the fourth. That is a mouthful. First thing I would definitely be looking for is greatest common factor. Be looking for a number or term that goes into all three. Well, variables are nice to work with first. because a does show up in all three terms. The smallest exponent attached to a is 1. So the most a's I can take out of all three is just a. Well, I do have b squared, b cubed, and b to the fourth. So the most b's we can take out of all three is b squared. Now we need to make sure that 186, 9, and 117 are not divisible or have a greatest common factor. Well, the only factors of 9, the smallest number, are 1, 3, and 9. 186, I'm just going to start with it. I'm going to divide it by 9. That doesn't work. Well, 3 does. But we do need to make sure that 117 is not also divisible by 3. It is. So that tells us 3 is also a greatest common factor. Now 186, if we divide it by 3, is going to give us 62. If I factor an a out of a cubed, we're left with a squared, and the b squared will factor out completely. Minus. If I factor out 3 from 9, 9 divided by 3 is 3. If I factor the a out of a, it simplifies. If I factor the b squared out of b cubed, I take 2 of the b's away from b to the third. We have b to the first, and we still have the c. Plus 117 divided by 3 was 39. If I factor the a out of a squared, we just have 1a. And if I factor the b squared out of the b to the fourth, we have b squared. And that's actually as far as it goes. Part of the reason I know that is mainly the variables. For this to work out with two variables, especially a squared and b squared, the a squared term, our 62a squared, is actually fine as it is. However, the 39ab squared would need to be 39b squared. We can't have that extra a there. Also, the middle term has to have ab. The fact that it has c is telling me it's not going to be factored. So this is actually as far as it goes. Questions on this here? So we're feeling comfortable with this so far? 19 through 24, any questions on those there? Still good with those? I'm not worried about 25, 26. Factoring by grouping is not going to show up. 27, 28, or 29? $29. 29 is interesting. X to the fourth minus 32x squared plus 256. This is actually factorable. It's factorable in a very interesting way. We can treat it like a quadratic. This is one of the ones I threw the term around throughout the chapter a few times here and there, quadratic-like equations or expressions. This would be one of them. I need to get some. And they can blame me. We would do the same thing. We would look for greatest common factor across these three terms. Since the third term is positive, the signs are the same. They match the sign of the middle term, negative and negative. Now, factors of x to the fourth, we actually have a few. We have x and x cubed, x squared, and x squared. For us, we're going to stick with x squared and x squared. We would have x and x cubed. For us to have that, we need actually 4 terms. 256. Well, I think 16 and 16 is what we're going to go with. There are a lot of factors at 256 we could go and write out. 16 and 16 is where we want to go. because x squared times negative 16 is negative 16x squared. Negative 16 times x squared would also be negative 16x squared, giving us negative 32x squared, yes? We're not done. X squared is a perfect square, yes? Is 16 a perfect square? So x squared minus 16 is the difference of perfect squares. X squared would be x and x. 16 is 4 and 4. So x plus 4 times x minus 4, yes? What's the other expression? X squared minus 16, which means it will also factor to x plus 4 times x minus 4. Yep. Interesting. But that's it for those. Any questions on any of the problems on the review sheet? Okay. If we're good, we'll stop there. Also, I would make sure to go back through. You feel comfortable with all the problems on there. Part 1's tomorrow, part 2's Friday.